Hello students, I am going to explain about a topic called friction. Different surfaces offer different amounts of friction. Smooth surface will offer small frictional force. What is frictional force? It is the force that opposes the relative motion between two surfaces. Suppose if there are two surfaces, a floor surface and a surface of the object, and out of these two surfaces, if the object begins to move, then frictional force will appear. So relative motion means out of two surfaces, one surface should move, or both surfaces should move with different velocities. Then only there will be relative motion, and hence there will be friction. And the origin of friction is linked to electric forces of atoms. See, I have shown here the bottom surface of the atom is going to have positive ions, and floor surface is going to have negative ions. The electric attractive forces between these ions is responsible for the presence of frictional force. Let us see that. When you apply external force on the object in the right direction, there is a attraction force between positive ion and negative ion. One positive ion is shown to be attached to bottom surface of the object, and negative ion is shown to be attached to floor surface. The attractive force between positive ion and negative ion is going to appear opposite to the external force, and this is called force of attraction between ions is nothing but frictional force. The frictional force always appears opposite to the motion of the object, and also here another important point is given. Friction force is like spring force. See, spring force is like this. Here a big block is there, on the big block a spring is attached, and end A is free end, relaxation state. Here the spring is in relaxation state, thereby no external force is applied, and the spring is in the normal state. In the normal state, no spring force, no external force. External force. Suppose if external force is applied, Ext is applied in right direction, then the spring will be compressed. Once the spring is compressed, immediately the spring will apply opposite spring force. Similarly, here also, when you apply external force on the object, then only frictional force will appear. If the frictional force is zero, if the external force is zero, frictional force will be zero. See that here in figure 1.4, when you apply external force of 10 newtons, frictional force will be minus 10 newtons. Why? Because frictional force is along negative x direction, external force is along plus x direction. If you apply external force to be zero, frictional force will be zero. By experiments, we can specify maximum frictional force for every surface. For every surface, we can specify maximum frictional force. For example, F maximum frictional is equal to 100 newtons for a given surface. If you specify maximum frictional force is to be 100 newtons, how can you specify? By doing experiments, you can specify. Suppose if this surface has maximum frictional force is equal to 100 newtons, the situation is as follows. Suppose if you apply 10 newtons, and then frictional force will be 10 newtons. If you apply 20 newtons, external force of 20 newtons, then frictional force will be 20 newtons. If you apply external force of 75 newtons, then frictional force will be 75 newtons. If you apply 100 newtons of external force, frictional force will be 100 newtons. But remember that 100 newtons is maximum frictional force. But once if you apply external force greater than maximum frictional force, suppose if you apply external force of 120 newtons, then friction force suddenly decreases to smaller value of 50 newtons. All these conclusions are expressed in terms of graph as shown in figure. Here a graph is shown. On the y-axis you are taking frictional force, on x-axis you are taking external force Fext, on y-axis frictional force. And here the graph can be divided into two parts, 0 to A and from C to D, or B to F, like that. Okay, anyway, the graph is in terms of straight lines. So to understand this graph, you need a straight line knowledge. Okay, for this I am taking this next slide. A straight line can be expressed as y is equal to mx plus c. or y is equal to ax plus b, or ax plus by plus c. All three equations are same. All three equations are representing same straight line on the graph. But for equation 1 and equation 2 are similar in appearance, but third equation appears quite differently. Even then, all three equations are representing straight line. Okay, let us briefly discuss about these equations in order to understand the graph of frictional force versus external force. Y is equal to mx plus c is a straight line. Y is equal to mx plus c is a straight line, and here multiplier of x is m. That multiplier of x is equal to m is nothing but slope of this line, and the line is making intersecting y-axis at one point, x-axis at another point. At the intersecting point of y-axis, the coordinates are 0, y, and y is equal to c. The c is nothing but the constant value mentioned in the equation. Similarly, the line is intersecting x-axis at a point x, 0. The value of x is minus c by m. The slope of this line is m. M is nothing but multiplier of x. Let us see the conclusions about y is equal to ax plus b. Y is equal to x plus b is a straight line making intersecting y-axis at one point and intersecting x-axis at another point. At the intersecting point of y-axis, you are finding 0, y. Y is equal to b. So b is called y-intercept. At the intercept, when the line is intersecting x-axis at a point, the coordinates are x, 0. X is equal to minus b by a. Anyway, the line of the slope of this line is a, where a is nothing but multiplier of x. And if a line is closer to y-axis, see, this is the line y is equal to mx plus c, a special line with c is equal to 0. When c is equal to 0, you will find that the line is passing through origin, and here the line is closer to y-axis, so the slope is very large. If a line becomes vertical, the slope is equal to infinity. Similarly, if a line is closer to x-axis, the slope is small. If a line is horizontal, the slope is 0. These are the conclusions that are required to understand this graph. This is frictional force versus external force. From 0 to a, the graph is very straight line, making an angle of 45 degrees. Making an angle of 45 degrees means y is equal to x. The graph is y is equal to x. Here on the y-axis you are taking frictional force, on x-axis you are taking external force. Therefore, the equation is the magnitude of frictional force is equal to magnitude of external force. Y is equal to x means magnitude of frictional force is equal to magnitude of external force from 0 to a. But at point a, the external force which is increasing from 0 to c, at the c the external force is becoming maximum frictional force. Once external force becomes maximum frictional force, suddenly the frictional force decreases to a constant value called FKF. For further increase in external force, the frictional force is no longer increasing but remain at a constant value called FKF. That FKF is called kinetic friction. And friction force, maximum friction force formula is mu s into n, and kinetic friction value, constant kinetic friction value is mu k into n. So okay, that is what you can see here. See, maximum frictional force value is mu s into n, where n is called normal force, mu s is called static frictional coefficient. The static frictional coefficient units are 0 and no units are there for this static frictional coefficients, because left hand side is force, right hand side is also must be force. N is a normal force. Normal force units are newtons, left hand side force units are newtons matched, and hence no units for mu s. Similarly, Fk is equal to mu kn. This is static friction, kinetic friction. This kinetic friction is equal to mu k into n. Mu k is kinetic frictional coefficient. N is called normal force. How normal force will enter into the discussion of frictional force, all those things you can understand while doing problems on friction. Okay. Now let us see that one peculiar case. Here object is shown in figure A and another object is shown in figure, but actually the two objects are same. But in figure A, the object is positioned in position such that only very little area of the object is making contact with the floor surface. But in figure B, very large area of the object is making contact with the floor surface. Now you see that here also the same reason, very little area of the object is making contact with the floor surface, very large area of the object is making with contact with the floor surface. And but in both cases, in both figures, what you will find that the frictional force will be same. Frictional force will be same. And most people think that since in figure A very little area is contacting with the surface, therefore frictional force will be small. But in figure B, very large area is making contact with the floor surface, thereby the frictional force will be large. But it is not the case. Actually, whether the area of contact is small or large, frictional force will be same. Let us see how it is. See, in figure A, only in figure A, only single point, very small portion of the object is making contact with the surface. Therefore, at this contact point, you will find only very few atoms. Say 10 atoms are there, and 10 atoms are making contact with the floor surface. But actually, the object weight means gravitational force. Object gravitational force is all acting on the few atoms of 10 Newton, 10 atoms. So, object, let us say, object gravitational force to be 1000, this is object force all to be acted on few atoms, and this force will be distributed, and force has to be distributed on very few atoms of the point of contact. Let us say each atom is experiencing 1000 newtons, but there are only 10 atoms at this point of contact. Then 10 into 1000 is equal to 1000 units. What I want to say is, since very little area is making contact with the floor surface, the gravitation force will be distributed on very few atoms at the point of contact. At the point of contact, I am assuming the number of atoms to be 10 atoms, and each atom is experiencing force of 1000 newtons. There will be 1000 into 10 is equal to 10,000 units. Now let us come to the figure B. In figure B, large area of the object is making contact. Also assume that in figure A and figure B, objects are same, and but in figure A it is oriented in one direction, but in figure B it is oriented in another direction. And where large area is contacting with the floor surface, thereby the gravitation force will be distributed on large number of atoms. Thereby each atom is experiencing very little gravitational force. Say each atom is experiencing a force of 0.5 newtons, but there are 20,000 atoms. So 20,000 into 0.5 is equal to 10,000 units. What I want to say is, previously you got 10,000 units by as equation 1-3. Now also you are getting equation 213, 10,000 units by considering figure B. In the equation 1-3 is obtained by considering figure A. Equation 213 is obtained by considering figure B. From figure A and figure B, the same values are resulted. Thereby you can say that frictional force will be same whether the area of contact is large or small. Whether the area of the contact is large or small. Okay, this is what I want to say. Thank you.